Welcome to the Unit 1, Section 7 video on solutions of inequalities. So just as we had special solution sets for equations, we can also have special solution sets for inequalities. Some inequalities are true no matter what value is substituted for the variable. For these inequalities, all real numbers are solutions. Some inequalities are false no matter what value is substituted for the variable. These have no solutions. If both sides of an inequality are fully simplified and the same variable term appears on both sides, then the inequality has all real numbers as solutions or it has no solutions. You will cancel the variable from both sides and determine if you have a true or false statement. So let's take a look at the solution sets. If you have a variable as part of your answer, then you have one solution set. But if the variables cancel and you have a false statement, you have no solution set. And if you have the variables cancel out and you have a true statement, then your solution is all real numbers. So let's take a look at a couple of inequalities. For A, first we have to distribute the 2, and then we have to add 8b to each side. Once we do, the variables cancel and we're left with 5 is greater than or equal to 2. This is all real numbers as our solutions because this is a true statement. Now, how do you handle this on a number line? Well, you just shade everything on the number line because every number is a solution. It doesn't matter what value you put in for B, you're going to end up with a true statement. Now for B, again, we have to distribute our -2, and then we are going to add 2n to each side, and that cancels out our variable, and we end up with -2 is greater than -2. Well, that's a false statement, so we have no solution set. What do you do with the number line when you have no solution set? You leave it alone. You do not shade anything. Just as you verified solutions for equations, we can verify solutions for inequalities. So to do this, we're going to have to check two things. We have to check the endpoint and the direction of the inequality symbol. So for this example, the solutions of x plus 9 is less than 15 are given by x is less than 6. So we have to check the endpoint first by using the related equation, x plus 9 equals 15. The endpoint should be a solution of the equation. So here, 6 plus 9 is 15, and 15 does equal 15, so our endpoint is good. Now we're going to substitute a number that's less than 6 in for x to see if the inequality holds true. If I put in 4 plus 9 is 13, and 13 is less than 15, so the symbol is good as well. When presented with a value for the variable as a possible solution for an inequality, it can easily be verified by substituting the value for the variable back into the original inequality, very similar to how we did equations. If the result is a true statement, the value is verified as a solution. If the result is false, the value is not a solution. So let's start with a couple of examples. For example A, n plus 8 is less than or equal to 13. We are trying to see if n equals 4 is a solution. So we substitute 4 in, 4 plus 8 is 12, and 12 is indeed less than or equal to 13. So the solution is verified. For B, we're going to substitute in -5 for h, and that's going to give us -25 is greater than -15. And so this is not a solution because that is a false statement. For C, we have -2/3 times s is greater than 6, so we're going to put -9 in place of s. And when we multiply those two things, we get 18 over 3. 9 times 2 is 18. Negative times negative makes a positive. 18 divided by 3 is 6. 6 is indeed greater than or equal to 6 because 6 is equal to 6. So the solution is verified. For D, we're going to put -4 in for B. 3/4 times -4 gives us -3. 2 times -4 gives us -8 on the right-hand side. -3 minus 2 gives us -5. -8 plus 8 gives us 0. And -5 is less than or equal to 0, so the solution is verified. For E, we're going to substitute -1 in for y. We're going to multiply those two quantities there. 7 plus 2 is greater than negative 3 plus 13. Perform addition on both sides. We get 9 is greater than 10, which is false, so it's not a solution. And then for f, we're going to put 3 in for k. 4 times 3 is 12. 3 plus 8 is 11. 12 is not less than 11, so it's a false statement, and so therefore it is not a solution. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.